Find the velocity of a 35 kilogram object that has a 450 kilogram meter per second of momentum. So we know momentum is mass times velocity. In this case, our mass is 35 kilograms and our momentum is 450. So we have 450 is equal to 35 times the velocity. Divide both sides by the 35, and we should get 12.86 meters per second for our velocity. Which has more momentum, and explain why? A car when it's going fast or slow? Well, momentum is mass times velocity, so it'd be a car going fast. Increase velocity is increasing momentum. A heavy or a light object going 10 meters per second. Well, a heavy object, because again, momentum is mass times velocity, and if we increase the mass, we'll increase the momentum. Find the momentum of each of the following objects. The first object is a 2 kilogram object that is going to the left at 40 meters per second. Generally speaking, we'll call the left negative and the right positive. That way we can incorporate direction in our calculations. This would be 2 times negative 40, which is negative 80 kilograms meters per second. Second object is 5 kilograms moving to the right at 10 meters per second. Momentum is mass times velocity. Momentum is 5 times 10, which is 50 kilograms meters per second. The third object is not moving, does not have a velocity. If the velocity is 0, the momentum is 0 because it's mass times velocity. Number 4, which of the objects in number 3 has a momentum with the greatest magnitude? Magnitude is looking at the number only, not the direction. So A is 80 when we look at magnitude only. Which of the objects in number 3 has the most inertia? Inertia is mass, simply mass. So which one has the largest mass? It is C with 40 kilograms. What is the difference between momentum and inertia? Momentum is mass times velocity. It's mass in motion. Inertia is mass. Number 7, a 2 kilogram ball at 4 meters per second to the right is kicked and later has a velocity of 8 meters per second to the left. Find the change in momentum of the ball. Remember, change in momentum is impulse. Change in momentum, mass times change in velocity, is impulse, force times time, depending on the information you have. In this case, we have a mass of 2 kilograms, V naught or initial velocity at 4 meters per second to the right, so positive. It's kicked and later has a velocity of 8 meters per second to the left, so we'll say negative 8 meters per second. We want to find the change in momentum. Well, we don't have force or time, so we're not going to use force times time, but we know impulse is equal to change in momentum, which is mass times the change in velocity. M times V minus V naught. The mass is 2, final velocity is negative 8, initial velocity being 4, final minus initial. Negative 8 minus 4 would be negative 12 times 2, negative 24 Newton seconds. Number 3, a 3 kilogram, our mass is 3 kilogram object going 6 meters per second. Our V naught is 6 meters per second to the right, so it's positive. Ends up going 3 meters per second to the left. So final velocity is a negative 3 meters per second. Find the change in momentum of the object. Change in momentum is impulse, force times time, or mass times the change in velocity. With the information we have, we do have the mass and we have a change in velocity. Mass is 3, final velocity is negative 3, initial velocity is 6. So negative 3 minus 6 would be negative 9 times 3 should give us a negative 27 Newton seconds. A brand new racquetball and a dog's tennis ball are thrown against a wall with an initial velocity of 10 meters per second. Our initial velocity for both objects, our V naught, is 10 meters per second. The racquetball, mass 0.08 kilograms, bounces off the wall with a velocity of, here we're going to say negative 10 meters per second because it's changed direction. It bounces off the wall. While the half-eaten tennis ball, mass 0.08 kilograms, only bounces off with a velocity of 2, so negative 2 meters per second. So we've got two masses, both the same, but the final velocities both negative, they are different. We're going to call mass 1 to be the racquetball. Mass 2 can be the half-eaten ball, or whatever is half-eaten tennis ball. So we're looking for the change in momentum of each ball, mass times the change in velocity. Final minus initial, so negative 10 minus 10 times the mass of 0.08. When we do the math, we should get a negative 1.6 Newton seconds. Negative 10 minus 10 is negative 20 times 0.08, so negative 1.6 Newton seconds. For mass 2, which is the half-eaten tennis ball, the mass here is 0.08 times change in momentum, negative 2 is our final velocity, minus our initial, which would be minus 10. So we've got negative 2 minus 10 is going to be negative 12. Negative 12 times 0.08 should get us negative 0.96 Newton seconds. And it makes sense that our answer is a negative change in momentum because we're moving in a positive direction, and then it is a negative impulse that causes it to change directions to a negative direction. Which ball delivered more force to the wall? Well, if we imagine the impact being the same, so the time is the same, but the force is different, the larger force will give us a larger change in momentum. M1, or the racquetball, has that larger change in momentum. Find the force that each ball exerted on the wall if the time of impact is 0.06 seconds. So we know for mass 1, force times time is equal to change in momentum, which we've already established is negative 1.6. Negative 1.6 is equal to force times time. That time is 0.06, right? We know the time from the problem. So if we take negative 1.6 and we divide by the time of 0.06, we can calculate the force to be negative 26.67 newtons. Our mass 2, the half-eaten tennis ball, same setup. We know that force times time, or force times 0.06, is equal to negative 0.96, our answer from number 9A. We divide over the 0.06 to calculate force, and we get negative 16 newtons. Looking on to number 10, a man pushes on a 4-kilogram box for 3 seconds. And they give us a diagram to the right. Under the diagram, calculate the initial and final momentum of the box. For the initial momentum, it's going to be mass times velocity. The velocity is 0, so the momentum is 0. For the P after, or the momentum after, we've got 9 times 4. 9 times 4 is 36 kilograms meters per second. So we've done the first thing. Calculate the impulse the man gives to the box. Well, we know impulse is force times time. They tell us that they don't give us the force, so we know that impulse is a change in momentum. If you go from final 36 minus the initial of 0, 36 minus 0 gets you 36 Newton seconds. What is the average force that the man applies to the box? Write it under the diagram. So we know that impulse is force times time. The impulse is 36, we figured that out a second ago, is equal to force times t, time is 3, they tell us that. So 36 divided by 3 should give us 12 newtons. And I put it over the diagram because they gave us a place to enter that where they say force is equal to 12. So let's just fix that in the question. Going to letter D, calculate the average force again, this time using mass and acceleration. You will have to find the acceleration with one of the kinematic equations. Does your answer agree with C? Well, V naught is 0 meters per second. That's the initial velocity. Final velocity would be 9 meters per second. Time, they tell us, is 3 seconds. And we're looking for acceleration. This looks like we can use our favorite equation, the only equation with a name. We have VOTAD, V equals V naught plus A times T. Initial velocity of 9 is equal to final velocity of 0. Final velocity of 9 is equal to initial velocity of 0 plus A times 3. Looks like my A looks a little funky, but we'll fix that in a second. So if we've got this, when we divide the 3 over, disregard the 0, we should get 3 meters per second squared is our acceleration. And let's just fix that previous line. Now that we have the acceleration and we know the mass, we can determine the force. Force is mass times acceleration, Newton's second law of motion. So force is equal to 4 times 3. And 4 times 3 is 12, so the force is 12 newtons. So it does agree with our answer in letter C. All right, number 11, new diagram. A 4 kilogram object is moving 15 meters per second. A force is applied to the left. Is the impulse positive or negative? Well, if the object's moving to the right and we apply a leftward force, we said going to the right is a positive 15 meters per second. So the force itself would have to be negative, and it's going to slow it down. It's opposing the direction of motion. Will the object gain or lose momentum? It's going to lose momentum. It's going to slow down. We know momentum is mass times velocity, so if we slow down, we're going to lose momentum. Fill in the information under the diagram and solve for the final velocity. Okay, well, the initial momentum is going to be mass times velocity, 4 times 15, which is 60 kilogram meters per second. The impulse is going to be 6 times 5, force times time, so 6 times 5. But keep in mind that 6 is a negative 6, so we should have a negative 30 Newton seconds impulse. So if we're starting with a 60, if our momentum is 60 and our change in momentum is negative 30, our final momentum is 30. Because you have 60, you take away 30, you're left with 30. And this shows us that Newton seconds and kilograms meters per second, they're the same thing. We just use Newton seconds in our impulse, in kilogram meters per second in our momentum. And solve for the final velocity. We know that force times time is equal to mass times the change in velocity. Our force is negative 6, our time is 5. That's equal to our mass of 4 times final velocity minus initial being 15. So if we get this all plugged in, I would distribute the 4 inside the parentheses and then solve on the left. On the left, I've had negative 30 is equal to 4v minus 60. Add 60 to the other side. Positive 30 equals 4v divided by 4. I should get 7.5 meters per second for final velocity. Number 12, 1,000 Newton force acts for 1 second on a 50 kilogram object which is initially at rest. What is the object's change in velocity? We're looking for change in velocity, which is impulse. Force times time is equal to mass times the change in velocity. Force is 1,000, time is 1, is equal to mass of 50 times the change in velocity, v minus 0. V being the final velocity, 0 being the initial velocity, all from the problem. So we end up with 1,000 is equal to 50v. Divide 50 on both sides, and we get 20 meters per second is the final velocity. The answer is B. The very last question, a baseball of mass 0.5 kilograms is thrown with a speed of 20 meters per second to a batter who hits the line drive straight back to the pitcher with a speed of 60 meters per second. Keep in mind here the ball changed directions, so the sign has to as well. The ball is in contact with the bat for 0.025 seconds. What's the force exerted on the ball by the bat? Well, we know force times time is equal to mass times the change in velocity. Force times the time of 0.025 is equal to the mass 0.15 times negative 60 minus 20. Final minus initial, the ball changed directions. Keep that in mind. So we get a force of negative 480. The answer choice is E.